So, yesterday we talked about 1 and 2. I gave you 3 and 4 for homework, yes? Okay, so what did you decide number 3 was called? Cube? Cubic is a little bit more accurate. It does have a cubed term in it. Okay, cubic is a little bit more accurate. But if this was on a quiz or a test or something and you put cube, I'm not counting that wrong. Okay? Alright, so what values did you choose for x? Why didn't you choose -3? I mean, we did on the first two, right? Oh, because that would be -3 and 27, right? Oh, excuse me, -27. And we can't graph -27 on this graph, right? So what'd you do next? -2, and you got -8. Okay, so -2, -8. And then what? -1 and -1 and 0. And then do you do 1 and 2? 1 and 2, so you got 1 and 8. Good. Did you connect them? How did you know you could? Do you remember? We talked about it some yesterday. Any of the points between, you could take 1.5 and cube it and get a value, right? Plus, how was it given to you? As an equation, right? As a function. So you know it is continuous, so we can connect them. Is that something we probably ought to put under special things? Yes, okay, continuous. I always have to think about that word because it's spelled weird. I mean, I shouldn't judge how a word is spelled. I'm sorry for that. Okay. What domain did you get? All real numbers. So that's our one notation. What's our interval notation? Good. -infinity to positive. Very good. What about range? Okay, so the same, right? All real numbers, negative to positive. Infinity, negative infinity, positive infinity. Any questions on that? I think most of you got that one pretty good. Okay. What about number 4? What did you decide it was called? So this one's kind of tricky. Not tricky so much as the fact that it actually has 2 names. It's known by 2 names. We have friends like that, right? That are known by 2 names. Okay. Do you know the other name that it's called by? Uh-huh. Very good. It's called radical. Do you know what a radical is? It's just that symbol. That symbol right there is actually called a radical. Now, we also call it a square root because that's what we most often use it as. We use that radical as a square root. But I just wanted you to know both names. Okay? How'd you go about choosing your x values for this function? Positive? Why'd you only choose positive numbers? Okay, so let me see if I'm saying what you're saying. Make sure we're saying the same thing. You said we can't take the square root of a negative number, right? Is that what you said? Okay, so can I make a correction on that real fast for you? You can't take the square root of negative numbers yet. Yeah, that's some foreshadowing right there. Okay, foreshadowing. All right, not today. Yeah, not today, but we will get there. You'll know how to take the square root of a negative number by the end of the course, for sure. Okay? So, no negatives. I'm okay with that. How else did you go about choosing your x values? Ooh, what do you mean by that? Ones you can do in your head. For example, ones that are easy to root, right? So you perfectly chose like squared numbers? Like what? 9, 4, 1, 0. Well, those are the only 4 squared numbers? They're the only 4 squared numbers that fit on the graph. Absolutely. Okay. So what is the square root of 9? 3. Oh, now I see why you mean nice numbers. Well, could you have chosen 5? Yeah? Oh, if you want decimals, right? We never, ever want decimals, do we? But sometimes we're going to have to deal with them, so we're going to might as well make friends with them now. Okay? What if you put in a 4 here? What's the square root of 4? And 1 and 0. Very good. And you plotted those points on the graph? 9, 3, 4, 2, 1, 1. Now you guys have to understand that this table right here would really, really bother some people. It doesn't start with the origin. It doesn't go least to greatest. Okay? I'm not one of those people. I can handle it. Okay? But if you're one of those people and want to erase that and put 0, 1, 4, 9, you just go right ahead. Okay? Can you connect it? How do you know? The numbers in the middle work, and it gave you an equation, right? A function. Okay. Part of the reason I know that all the points in the middle work is because it gave me a function. Because any value that I put in for x, I can get a value out for y. In this case, as long as it's a positive value. Okay, so I could choose 2.5 for x if I wanted to, because I could use a calculator and find the square root of 2.5. Okay, that's a good question. All right. So what's its domain? Okay, you guys did really good on that one. X is greater than or equal to 0. And you even told me the range really good. Y is greater than or equal to 0, right? Almost every single one of you had that on your paper. Now, a couple of you messed up your signs, so if you messed up your signs, go ahead and fix them, please, so that they're correct. Okay? But what you forgot was the interval notation, didn't you? So it's either that you forgot or got confused. Either one of them at this point is acceptable. Okay? But we want to fix it. How would I write that domain in interval notation? And some of you even got this far, and that was great. And some of you even got that far, and it was great. But the one sign you missed is the fact that 0 is part of our domain. Look, it's right there. And so this is a bracket. Okay? When it's part of the domain, when it is included in our values, we use a bracket. Why don't we use a bracket on this side? Yeah, do you know where the end of infinity is? Yeah, me neither. There's not such a thing, right? So we say infinity and just kind of put the parentheses there to say, I got to have some sort of closing mark. I'm just going to use a parentheses. Correct. This says it starts at 0 and goes all the way to the right. Which, if you think about it, that's exactly what this says, doesn't it? Okay? Yes, ma'am. Can we look at that one in just a second? Let's finish this one. We'll go back and look at that one. Okay? So what about this one? It is the same thing, isn't it? Starts at 0 and goes to infinity. What special things did you list? Continuous. Say again, please. It doesn't go to negatives? Anybody else? Some people earlier put this, that it was a curve. Is that good? Okay, so checking out number 2 real quick. Your domain for number 2 should be all real numbers, negative infinity to positive infinity. Your range for number 2 should be y is greater than or equal to 0. So it should be bracket 0 to infinity. Okay? If you didn't have that before, are you fixing it now? Good, thank you. Okay? Any more questions on number 4? No? Because you have to really understand number 4 before we can talk about number 5. Are number 4 and number 5 really any different? They are different, aren't they? What does this one have that the top one doesn't? A little baby 3 right here, right? Does this one have anything that's a little baby? Oh, it does though. It's not a 0 and it's not a 1. What's this called again? A square root. So guess what's here? A 2. Why don't we write that little baby 2 right there? It's implied. It's understood. It's one of those things that this is what we almost always use a radical for, is square root, so we don't have to write the little baby 2. Okay? That's also not the actual technical term for it. Little baby 2, that's not the right term for it, right? Okay? Because you understand what I'm talking about when I say that, so we're okay saying that right now. Okay? What'd you say? Oh, that's so good. Cube root. It is the cube root. Okay? So, thinking back to how we went about choosing numbers for this, how do you think we ought to choose numbers for this? Same way? So we should choose 9, 4, 1, and 0, and... Oh, no? Oh, the same process. Oh, okay. So what do you think I should choose? It has to be what? What'd you say? Oh, yeah, we want it to be below 10. So what number times itself, what number is that going to be that's below 10? 8. So if I put in an 8, what times itself equals 8? 2. Very good. Now, are there any numbers like this that are above 10? Well, heck yes, a whole bunch of them, right? But we really only care about the 10s right now because of what our graph looks like. Would it be wrong for me to put 27 right here? No, because I could put 3, because that's right. I just can't graph that one. Okay? So what else could I put right here for x? 1. What times itself is 1? 1. What else could I put there? 0. Good. What's that one? 0. Okay. Is that it? Yeah, why can you? What times itself equals negative 8? Negative 2. Okay? Negative 8 will be negative 2. Now, that's a different way of thinking than up here, right? You can't just see a radical and automatically think, oh, that we can't do negatives. It depends on what this number is right here. Whether that number, I don't want to spoil anything, but, when we talk about radicals, if that number is even, can't do negatives. But if that number is odd, you sure can. Okay? So then what other one could I have here? Negative 1. We absolutely could put negative 27, couldn't we? And what would that give me right here? Negative 3. Okay. So let's plot these points real quick. 8 and 2. 1 and 1. 0. Negative 8. Negative 2. 1. Can I connect them? How do you know? It's a function. Oh no. Can you use your imagination that my curve went through that dot, please? Thank you. Huh. That's weird. This one right here? Doesn't that kind of look like that one right there? It's like kind of to the side a little bit. Oh my gosh, look what that exponent is. Look what that little baby number is. You think those might be related somehow? Guess what that is? Foreshadowing. Yeah, more foreshadowing. Tell me what the domain is. All real numbers, very good. So negative infinity to positive infinity. What about the range? All real numbers, very good. Anything special we want to write? Continuous? Anything else? Curve? Anything else? No? Earlier they wrote, looks like an S. I'm like, you go right ahead and write that. That's just fine. Okay? Any questions on number 5? Okay, let's go to number 6. Where do you want to start? Can you do the domain and range before you do the table and the graph? I mean, maybe, right? Maybe if that's a function you know of, that you've heard of before and you remember what it is. For a function like this that you haven't seen before, is that the best idea? Nah. So maybe we don't want to do this first. Can we do the graph without the table? No. So we have two places we could start. We could start with the table or the name. Name? What do you think it's called? It looks like a fraction, doesn't it? So that might be related to the name, but I'll give you a hint. It starts with an R. Rational, very good. Ratio. That's where the word comes from, right? Rational. So, where do you want to start? Table, okay. Well, what value do you want to choose first? 10. Let me ask you this. What do you think is the most popular value that people have wanted to start with today? Nope, it's not 10. It's not 1. 0. 0 is the one that they wanted to start with today. Anybody see a problem with that? Can you divide by 0? There's only one person I know that can divide by 0, and Chuck Norris is not in this class. No. Okay? So I'm going to go ahead and put it on the table, though, because I want us to remember that we talked about this. Okay? If I put in a 0 here, what do I put here? Heck. I can't do that. I mean, I guess you could put error if you want, but that's boring. Or undefined. That's even worse. That's super mathy. I'm just going to put ACK. Okay? Now, undefined, for the record, is the actual term that we should put, if you want to put that. But, again, I'm just going to put ACK. Okay? No, not if I do it. Yeah. Okay, so what else should I try? 1. That's been the most popular second guess. Do you know what 1 divided by 1 is? Oh, good. We can do that, right? Not a problem. What's next, do you think? 2. Good. 1/2. Okay. Then what? 3 and 4 and 5 and 6, all the way up to 10, like Kyle wanted to say a minute ago, right? But that's not really going to tell us a whole lot of information about this graph. So would you please trust me for a minute and let me kind of steer you where I need you to go? Is that okay? So the next thing I want to put then is 5. Okay? So what would this be? 1/5. Okay? So, not counting all the ones I just said, what else could we try? Where did we go up on number 5? After we tried these, where did we go? Negatives. So what if we tried -1? Would that work? Okay. So -1/2. Excuse me. It's just -1. I'm already telling you the answer to the next one. Sorry about that. -2. Okay. Oh, that one's -1/2. Sorry about that. What do you think we ought to try next? -5. I'm okay with that. Now, I need to blow your mind for just a second. I know, second day of school, you'll be able to handle it. Okay? What if I chose 1/2 for my x value? How do you know that? I mean, it's right. I just want to make sure you know how you know that and not just like guessing. Can I show you the math? Is that okay? Now, a lot of you know that because when you put it in the calculator, that's what it tells you, right? But right now, I need you to understand the math because I know where we're going, and I need you to understand this part of the math so that when we get there, it'll make sense. Okay? If I say 1/1/2, are we allowed to have a fraction in the denominator of a fraction? No. Do you remember how we get rid of fractions in the denominator? multiply by, starts with an R, and it's not radical or rational. REC, reciprocal, right? Okay. So if I multiply this by the reciprocal, if I multiply the denominator by the reciprocal, what else do I have to multiply? The numerator, right? So 2 over 1. Well, when I multiply across, I get 2 over 2. What is 2 over 2? 1, right? 2 divided by itself is 1. So that's a 1. So it's like the denominator's not even there anymore, right? Because we don't have to write a denominator if it's 1. What do I have left in the numerator? 1 times 2. 2. That's the math I need you to know. It's great that you know how to use a calculator and punch buttons. Monkeys can do that. I like monkeys, don't get me wrong. Okay? I need you to understand the math. So what if I choose 1/5? What's that going to be? 5. So what else could I choose? Negative 1/2, which would give me negative 2. And I could choose negative 1/5, which would give me negative 5. Okay? Very carefully plot these points. What do we do at 0? Nothing, right? We don't do anything at 0. We can't plot anything at 0. But before you, can I connect these points once I get them drawn? Is there a function that it gave us? Yes, so I can connect the points. But please, before you connect the points, look at mine. Okay? I mean, not yet because I haven't drawn them yet. But before you draw yours, look at mine. Okay? Go ahead and plot your points. Okay, do you see how mine are connected? Did I cross over the x-axis? Not during class, before school or after school. Did I cross over the x-axis at all? Did I cross over the y-axis at all? Okay, so I even don't think I did a really good job of this. I did as decent of a job as I can as a human. Okay? Because what's happening with this? Where's it going to go? Is it going to come back around like this? No. It's going to get closer and closer to the x-axis. Will it ever touch the x-axis? It won't, will it? Okay? There's no y value right here that will ever be 0. No x value that I can put in to make a y value 0. Because as long as this even if it gets smaller and smaller and smaller and smaller, that's just going to make this number bigger, bigger, and bigger, bigger. It's never going to be 0, is it? Now, guys, that's not something that's easy to understand as a human. Infinity is hard for us to kind of comprehend in our brains. Okay? I definitely can't draw it. That's for sure. Okay? So where's this one going to go? Closer and closer to the x-axis. Will it ever get to the x-axis? No. Because there's no value of x that I can put in that would make that work. What is there? Okay? So what's the domain? Is it? Is it 0? So, other than 0, is it all real numbers? Yeah. So here's what we can do. We can say all real numbers, but then I can clarify it by saying not 0. It's everything but 0. All real numbers, x is not equal to 0. Same thing for the range. All real numbers, except this one's a y, right? Y is not equal to 0. Now, it's the interval notation that I don't want you to let be tricky. Okay, so watch me write it. It's going all the way to infinity, right? And then it gets to 0, but nothing can be at 0. So that's the end-ish, right? But 0 is not included, right? It's here, but there's no value for it. So I use a parenthesis this time. And then I write a U, which stands for union. And in interval notation, like terminology, that means and. And then again, it starts on the other side of 0 and goes to infinity. Does that make sense that that says the same as that? Absolutely. Okay. What about the range? Same thing. Negative infinity goes all the way down. As it's coming up, it's getting closer and closer to 0, but never touching. So I use a parenthesis. And then on this side of 0, it starts and goes all the way to infinity. Good? What kind of special things do we know? Okay, so I have to teach you a word, mostly just so we can write it down here, but we're not going to talk about it yet. Okay? There's asymptotes. I think it's a funny word. Most of the time I'm using it inappropriately because I'm saying, JD, I'm going to kick your asymptote. That's not a really nice thing to say, and you shouldn't say it in front of adults who don't know what it means because then you'll get sent to the office. Okay? So don't do that. Please. Okay? What else should we write under special things? What'd you say? So we don't have to write that, even though that's very true, because that's what that word means. Okay? It's not going to cross 0. It's not going to touch 0, because right here, there's an asymptote. And right here, there's an asymptote. And I know that you don't know what that means yet, but we will get there, I promise. Okay? Now, it does look like it reflects, doesn't it? Okay? Now, earlier, you know what they said? They said it has two parts. Well, I asked if we could change that a little bit, because does it actually have two parts? No, but it doesn't look like it has two parts. Okay? So it looks like it has two parts. It's one equation, one function. This is what that function looks like. It looks like it has two parts. Okay? Anything else? Curve? Okay? Continuous, absolutely. Good? All right. 7 and 8 are what I want you to do before you get back to class next time. Okay? Before I let you go, though, please understand. Look up at the board real fast. What's the difference between these two equations right here? Nothing. Okay? This is saying, though, we want B to be between 0 and 1. Are there even numbers between 0 and 1? Fractions, right? Now be careful of that. Make sure you're understanding that it's a fraction between 0 and 1, because we can't use 3/2. Because while 3/2 is a fraction, it's not between 0 and 1, right? So as a group, since we're working on this together, let's all decide to use the same B value. What's the best B value for us to choose between 0 and 1? Absolutely. So for this function, let's use the equation f of x equals 1/2 to the x power. Because on this table, we're not trying to guess B, are we? We're not trying to input a B value. We're trying to put in an x value to get a y value. Same thing applies for number 8. I need a B value that is what? Greater than 1. What's the best one to choose for that? 2. So let's all use f of x equals 2 to the x power. Okay? Any questions about that? Okay? If you do have any questions, what should you do? Tutorials is great. Okay? Before school and after school. Any other questions? Peace.